the previous videos, we mentioned about the details that you can acquire from the architectural drawings. These include the floor plan, the views, as well as the cross sections. So far we have covered about the floor plans and demonstrated how those informations are being presented, such as the grid line dimensions, the room and spaces, the building elements, architectural fixtures, and etc. In these videos, we're going to proceed our discussions with the view of the buildings. Normally, there will be at least 4 views of the building, which is the front, the rear, the left, as well as the right. From the view of the buildings, we are able to see the story height of the building, the gutter of the building, the facade and the architectural fixtures, the building elements, wall heights, railings, and others. Now let us take a look on some examples of the views of the buildings, which is given in the architectural drawings. In this case, to know the view of the building, you will need to first refer to the floor plan. Taking this as an example, this is a ground floor plan, and you see the symbols at the 4 sides of the floor plan, indicating the directions of the views. Look at the numbers of the views. It is stated that view 1 is the front view, view 2 is the right view, view 3 will be the rear view, and view 4 will be the left view. This is the view 1, which is the front view. This is the view 2, which is the right view. This is the view 3, which is the rear view. And you have view 4, which is the left view. From the view of the buildings, taking this front view as an example, you will need to read it in reference to the grid line. This grid line here, Y1, Y2, Y3, and Y4, should be in line with the floor plan Y1, Y2, Y3, and Y4. Same goes to the rear view. You will need to refer to the grid line. Only now the numbers of the grid line is in the reverse manner, where you have Y1, Y2, Y3, and Y4. Similar principles applies to the view 2 and view 3, which you will need to refer to the grid line X1, X2, X3, and X4 that are in line with the floor plan X1, X2, X3, and X4. Now let us look at the informations that you can acquire from the view of the building. First, it gives you an idea how the building should look like when it is fully constructed. You may refer to the floor height as indicated here. There will be roof level, ground floor level, first floor level, lower roof level, attic levels, and the dimensions are given here, which you know in this case the ground floor level is slightly higher than the roof level by 450 mm. The height of the ground floor level is 4.2 meter. The height of the first floor level, it will be 3.8 meters. You will see the doors, window frames are indicated at their intended height. It shows you how the roof will look like, providing you the details of the roofs, which in this case is concrete tiles roofing, and it is dated to manufacturer details. There is aluminium roofers here, made of aluminium hollow sections, and the dimensions are given, as well as the spacing of the hollow sections is also given, and it is stated that to manufacturer details. The height of the brick wall is also given, as well as the height of the glass wall, which it is stated that 300 mm height of brick wall with 600 mm height of the glass railing. Again, this is to the manufacturer details. It provides information regarding the doors and windows, where there are numbers indicated that you can refer from the schedules of doors and windows. You will see the gutters and the facade of the building, and this is the rear view of the building. Similarly, you will be able to view the building. How does the windows look like? What are the details of the elements? How does the balcony looks like? And also the details of the RC gutter. And from the right view, you will see columns. Some of these columns is going to be for architectural purposes, the story heights, and etc. You see, most of the students, when they need to design a building, producing a structural plan, they refer more extensively to the floor plans given in the architectural drawing. Most of the time they overlook the details of the view of the buildings, where there are some informations can only be acquired from the view of the buildings. This includes the story height, as well as the height of certain building elements, such as the wall, the railings, and etc. The view of the buildings also give you an idea how would the building looks like. And when you design your structural plan, you need to ensure that the intended view of the building is not being compromised. Next, we will look at the cross-section of the building, which typically appear in the XX sections and YY sections. The cross-sections also give you a lot of informations, particularly the headroom of the rooms, the ceiling depth, the gutter and drain sections and the elevations, drop or rise of the slabs, the surface gradient, the staircase sections, the concrete fin sections, the story height, and etc. Let us look at an example. Again, you will need to come back to the floor plan. You see there is a horizontal line and a vertical line indicated here. That means there will be two sections, one in the XX, another one it will be in YY. This is the XX sections, which you see the building is cut into half, showing all the internal part of the building, including the structural elements, such as the slabs and beams, as well as whichever you can view from the building. This will be the YY sections, which is also being cut into half, showing the internal part of the building, and this allows you to cross-check your design in concurrent with your floor plan as well as the view of the building. Let us take a look in terms of the informations given in this section. There will be story height. This information should be cross-checked with the view of the buildings, which in this case is in line. It indicates the levels, the ground level, road level, first floor level. From the view of buildings, we observe the balcony, which was mentioned that there is glass railings, which can be indicated here. We also see the sections of the gutters as well as the architectural fixtures where the dimensions are given. If you see the section here, this will be the gutter, and this will be a part of the architecture fixtures. You have one more here. You will have to imagine how you're going to reinforce this RC gutter, as well as how you're going to keep this in place. It cannot be simply attached to the brick wall, as the brick wall is non-load bearing, and you see the extensions of the member from the brick wall. It would behave as a cantilevers. The dimensions are given. You may also do some measurements to confirm the dimensions, which in this case, most likely you're going to do this in one piece. That means the gutter with combinations of this. The shape will become something like this. And you will need to put into the reinforcement to ensure the stability of the structure. And you will see there is a window here. Now you will need to check the size of the window. This is the window 14. The height is 450. The width is 1.4 meter. It is placed at 2.8 meter from the floor. And then you will need to check from the side of the building, which is the view 4 of the building. We are talking about this gutter, this architecture thing. The windows are here, and there is another extension here. You will need to find a mechanism to support this part. Probably you might need reinforcement bar along here in order to hold this piece of concrete element. These are something that you have to take into considerations. Same goes to the gutter on the other side. This is the dimensions of the gutter, and there is a minor part of the extensions of concrete. Most likely you're going to make it in one piece, and that the dimension, it should look something like this. Then you're going to put into the reinforcement bars to ensure the stability of the members. Don't forget about this also. Now this won't be a typical beam. You cannot rely on the brick wall here to support this horizontal concrete member. That means this again needs to come in one piece. Most likely the section will look something like this. So that it is able to support the wall here. The dimensions are given here. There is another type of gutter here. This one is relatively easy, and it is meant for the facade of the front view of building. You may design in accordance to the sections proposed, and it is stated that the RC gutter to engineer details. As long as it doesn't affect the view of the building, the architect should be okay with your design. You will also see the sections of the perimeter drain. Normally it is given by the architect and stated to engineer's details. That means you need to design it. And most likely you're going to design this as a cantilever in order to carry the weight here as well as the weight of the perimeter drain. You will also see the drops of the slabs, which in this case is referring to the bathroom. There is a 75 mm drop from the bedroom, and you see there is a 50 mm curb, which you can notice from the floor plan given, and the balcony here. There are informations given on the headroom, which through plus and minus you will know the space allocated here. This will be the ceilings. The material will be to the manufacturer details, but the structural element such as beam, it will be designed by engineers. By all means, you should keep your structural element to be within the allowable space within the ceiling. Unless you cannot fit in the size within the space, you will need to seek consent from the architect whether this headroom can be revised. You cannot simply put any size exceeding the limits given in the ceilings, as this is going to affect the aesthetic view of the building. The best conditions of view is for you to hide the structural element, particularly the beam, within the ceiling. From this section here, you only so see that there are differences in terms of the level of the beam of the building body as compared to the level of the gutter, which is meant for the car porch. The reason is due to the gradient of the roof at the car porch. In the case that you have extended beam to connect to the gutter, you need to particularly concern about the level of the members so that it doesn't look awkward after the constructions. You also see the details of the staircase. On this part, you will need to do some counting and check against the details given in the floor plan in terms of the numbers of rises, the dimensions. The R represent the height of each step, and the T represent the width of your footstep. And you might need to do some simple calculations to cross-check the numbers of the footsteps so that it fits to the level of the building. And then you can adopt the design of the staircase and incorporate reinforcement bar within the staircase. In this case, the staircase seems as if a cantilever staircase. It is for you to decide whether you want to make it cantilever or you will need columns along this side of the staircase. This one you will need to check from the view of the building. You know that the staircase is in front of the windows, and these windows are to be installed onto the column here. You will need to decide the positions of the column if you really need the columns for the design. Most likely you're going to put an additional column here to support the landing beam. Since that we're talking about the landing beam, this will be the landing beam, and based on the staircase design here, the staircase will go up here and then go up to these directions and then go up here. You have to consider the design of the staircase. You might need column to support the landing beam, and this landing beam is not on any of the floor plan. This will be the ground floor plan. This will be the first floor plan. That means you need to provide an additional beam here to support the slabs of the staircase, and this needs to be clearly indicated where it should be placed. Also mind the special design here, which you need to compare with the floor plan in order to observe what this is actually. Most likely there is a flat slab with certain degree of the gradient so that the water can flow from the roof onto the slab, and then to the gutter. There is another special features here. You will need to pay extra attentions. Again, you will need to refer to the building in various aspects. Most likely looking at the view as well as looking at the plan in order to figure out what are these. Same goes to this part. You might need to study and imagine what are these. Most likely this is a roof extended from the wall, which is not RC roof. What you see here, there are a lot of information that you can acquire also from the cross sections of the building. In order for you to design properly a structure, in fact you have to refer all the details given in the architectural drawing to figure out what it is, how it should look like, and how you're going to design it. Most of the students refer more extensively on the floor plans, and they forgot the importance of looking into the details given in the view of the structures as well as the cross section of the structures. There are a lot of valuable informations which you cannot acquire in the floor plan, or which is difficult for you to imagine by just referring to the floor plans. I would say that the students who are producing a better design, or the largest difference between the good students and the poor students, I mean in terms of the design, it will be due to those minor details as reflected in the views and the cross sections. We can observe from the gutter design, we can observe to the beam sections which are necessary to hold the architectural thing, and so on so forth. You need to know that the contractor will build the structures in accordance to what you have drawn in your structural plan. If it is not drawn, you cannot expect the contractor to build it. The worst case scenario it will be, after building the structures, only then the contractor realizes that some mechanisms are required to hold the architectural fixtures, and then whichever remedy that associated to that particular issues is going to be costly, and this is going to delay the project. You should have all this considered upfront before the commencement of the project.